Well, we've got four things to do here. Find two X-intercepts and two asymptotes. So for the intercepts, we've got for X-intercepts, that's where you set the function equal to 0. And if you set this function equal to 0, the only way it can equal 0 is if the top equals 0. So the only way a fraction ever equals 0 is if the top is equal to 0. So x squared minus 4x minus 8 set equal to 0. And then I don't think it's going to factor, so rely on the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, a negative 8, all divided by 2 times a. So it's going to be 4 plus or minus, this is a 32 positive, with this makes 48. And usually I would say this needs to be reduced. I did a 16 times 3 and take the square root of 16. But since we're going to be graphing it, I would like to have decimal answers. So what are the decimal answers here? So 4 plus the square root of 48 gets divided by 2, and then hit second enter, back up, and change this to subtract. So a 5.464 and negative 1.464. There's the X-intercepts. And then for the Y-intercept, well, for that, you go to the function and plug in when x equals 0. So g of 0 is going to be 0 squared minus 4 times 0, subtract 8, and then 3 times 0, subtract 4. So these zeros are going to cancel. It really leaves a negative 8 divided by a negative 4 is 2. So it goes through when x is 0, y is 2. So it should be crossing the x-axis at these values and crossing the y-axis at this point. Okay, that takes care of intercepts. And now on to asymptotes. First, I'll do the vertical asymptote. And that's where the denominator is equal to 0. So where is the function undefined? So add 4 to both sides. Divide by 3. So the function is undefined at 1 1/3 or 4/3. And then, let's see, with the degree on this one being 2 and the degree on this one being 1, if you were to look at just those terms and reduce, it would leave x over 3, which is basically a line with a slope of 1/3. That means that we've got an oblique or a slant asymptote. There is no horizontal asymptote. And the equation of the slant asymptote is essentially 1/3 x. So it's a line with a slope of 1/3. But if we have a line, we need not only the slope, but the y-intercept b. To get that, use long division. So 3x minus 4 gets divided into x squared minus 4x minus 8 And to get an x squared here, I do need an x, so that x times x is x squared, but I need to eliminate the 3. And so do that by multiplying by 1/3. Or that's essentially this x over 3 that I was talking about when I looked at the leading term for the numerator and the denominator. Well, then distribute, so we've got this times this is just going to be x squared. And then this times this will be 4/3 negative times an x. And then we need to subtract this whole second line. So it's going to be x squared minus x squared, which is good news. And then we've got -4 combined with a positive 4/3. So to save a little bit of space, since I'm running out of space, I'll use the calculator. -4 plus a 4/3, but I need to keep this in fractions. So go to math, and the first one, change it to fractions, -8/3. So these two combined make -8/3 x, and then carry down this -8. Now keep in mind, what I'm trying to do is find the equation of the line. 1/3 x plus or minus what? Once I find that number, I can stop the long division, because I don't need to know what the remainder is. I just need to know what's the equation of this line that's going to be the slant asymptote. So next, I need a -8/3 x. Well, this already has the x. To get an 8, I'm going to have to multiply by 8. And to get the 3 in the denominator, I'll need to divide this by a 9. So I need to use -8/9. When I multiply over here, I will get the 3 going into the 9 3 times for the denominator, and the numerator will have the -8 as needed. And so we can stop there. The slant asymptote is y equals 1/3 x minus 8/9. And then I need to verify, so I'm going to graph, first of all over here, and then I'm going to graph with the calculator to see that I got it right. So at x equals 5.464, it crosses the x-axis. Over here at x equals -1.464, it crosses the x-axis. It crosses the y-axis at 2. At 4/3, so that's about 1 1/3, let's say right here. At 4/3, there's an asymptote. So I put a dotted line to indicate that the function is undefined there for that vertical asymptote. And then this is the horizontal asymptote. So if you go down to -8/9, which is not very much, that's where this crosses the y-axis, and then has a slope of 1/3. So it's not a very steep line, but it is going up. Didn't mean for it to go through at 4/3. Not sure where it crosses. This one crosses the x-axis, but that's the general shape of it. And then the function is going to have two branches, something like this. And let's verify with the graph. So the original function, put parentheses for the numerator, is x squared minus 4x minus 8. For the denominator, 3x minus 4. And then zoom standard. And it seems that the function is down here. And over here, right there it crossed at trace negative 1.464, so that's where it's crossing the x-axis. Then it crosses the y-axis at 2 and goes up. One other thing I want to do is verify that I got this line correct. So if I also graph the 1/3 x minus 8/9, and I make this a thicker line, then that should, in here, go right through the 2. And as these functions go off to the left and to the right, or to the left and to the right, the function is going to get closer and closer and closer to that line. So it looks like we've got everything right.